Good morning. Today our new topic is working of two-stage RC coupled amplifier. Working of two-stage RC coupled amplifier. Next, recap of this presentation. In previous class, we discussed about, we know that need for multi-stage amplifier, gain, decibel, frequency response and bandwidth of an amplifier and gain of a multi-stage amplifier and also problems. So these topics are completed in previous class. Next, objectives of this presentation. On completion of this period, we would be able to understand the working of two-stage RC coupled amplifier and summary. The working of two-stage RC coupled amplifier and summary. Okay. So working of two-stage RC coupled amplifier. Okay. So this is the figure of two-stage RC coupled amplifier. Show dotted line. See the dotted line. So before dotted line is first stage and after dotted line is second stage. Cc is the coupling capacitor. So what is the purpose of coupling capacitor here? To couple the output of first stage to the input of second stage. Coupling capacitor is connected to the output of first stage to the input of second stage. Okay. So next, actually this figure shows two-stage RC coupled amplifier. Cc is the coupling capacitor. It connects the output of first stage to the input of second stage. Since coupling from one stage to the next stage is achieved by coupling capacitor along with a shunt resistor. That's why this amplifier is called RC coupled two-stage amplifier. Since the coupling from one stage to the next stage is achieved by coupling capacitor along with a shunt resistor, that's why this amplifier is called two-stage RC coupled amplifier. So this method of coupling is widely used in cascade amplifier stages. This method of coupling is widely used in cascade amplifier stages. Okay. See this figure. So this is the figure of two-stage RC coupled amplifier. See this figure, first stage and also second stage. So both stages, see this R1 and R2. The two resistors R1 and R2 form the self bias. The two resistors R1 and R2 form the self bias. So what about Re? Re is the emitter resistor. It is used for stabilization network. Okay, it is used to stabilization network. Re from stabilization network. So Re is connected parallel to Ce. Ce is bypass capacitor. Ce is bypass capacitor in both stages, first stage and also second stage. What is the purpose of Ce is connected parallel with Re? It offers low reactance path to the signal. So gain of the amplifier is not loss. So if it is not connected in this case, Ce is not connected, so gain, some signal gain is loss. That's why, so we can't lose the gain, then connect emitter capacitor, that is bypass capacitor parallel with emitter resistor Re. Okay. So I repeat once again this point. The resistors, two resistors R1, R2 forms self bias. Re form stabilization network. The emitter bypass capacitor Ce offers low reactance path to the signal. So the gain of amplifier is not loss. Okay. So next, the coupling capacitor. Coupling capacitor Cc here helps in, what is the purpose of coupling capacitor? Helps in blocking the flow of DC components from first stage to the second stage. So actually, what is the purpose of coupling capacitor? It connects output of first stage to the input of next stage. In this connection, the coupling capacitor helps in blocking the flow of DC components from first stage to the second stage. Thus, the biasing of second stage will not disturb. Thus, the biasing of second stage will not disturb. Okay. So, next, this is the construction and connections and also working principle of all components of first stage and second stage two stage RC coupled amplifier. Okay. Next, working principle. Working principle of two stage RC coupled amplifier. When the input voltage VI, input voltage is the VI that is applied to the base of first transistor through input capacitor Cin, it appears in the amplified form across its collector load resistor. See this figure. So, input voltage VI is the input voltage that is applied to the base of first stage of applied to the base of transistor through input capacitor Cin. It appears in the amplified from across its collector load RC. The output of first stage is given to the base of the next stage through coupling capacitor. See this figure. The output of first stage to the given to the input of base of the second stage. Okay. Next, the amplified signal of first stage gets further amplification by the second stage and hence more amplification takes place. The amplified signal of first stage gets further amplification by the second stage and hence more amplification takes place. So, the output of second stage is taken out through the coupling capacitor. The output of second stage is taken out through the coupling capacitor. Therefore, the overall gain of amplification, that means either first stage and also second stage, the overall gain of amplification first stage and second stage is equal to product of the individual stages gains. Okay. Therefore, the total gain is equal gain of first stage into gain of second stage. Gain of first stage into gain of second stage. Okay. So, this is the working principle of two stage RC coupled amplifier. Okay. Next, frequency response of two stage RC coupled amplifier. Frequency response of two stage RC coupled amplifier. So, the frequency response of RC coupled amplifier is the curve between the gain of amplifier versus the frequency of input signal. Okay. See this figure. Frequency response of RC coupled filter. See this figure. This curve, this response, frequency response. So, where is? So, here x-axis is taking on frequency in hertz and y-axis is taking on gain in decibels. Okay. So, the frequency response of RC coupled amplifier is the curve between the gain of the amplifier and frequency response of input signal as shown in below figure. So, this frequency response has three regions. See this frequency response curve. This curve has three regions: low frequency range, mid frequency range, high frequency range. Low frequency range, mid frequency range, high frequency range. What is the frequency range of low frequency, mid frequency and high frequency ranges? 0 to 50 Hz. That means less than 50 Hz of frequency is used for low frequency range. What about mid frequency range? 50 Hz to 20 kilohertz. 50 Hz to 20 kilohertz frequency is used in mid frequency range and is greater than 20 kilohertz. More than 20 kilohertz of frequency is used in high frequency range. Okay. These are three regions. So, one by one discussed briefly. First one, low frequency range. First one is low frequency range. So, low frequency range, what is the frequency range? Less than 50 Hz. The frequency is inversely proportional to the capacitance reactance. Here the frequency is inversely proportional to the capacitance, reactance. So capacitance reactance is denoted by Xc. Xc is equal 1 by 2 pi R into C. So the reactance of coupling capacitor Cc will be quite high at low frequencies. See this figure. The reactance of the coupling capacitor will be quite high at low frequencies. Hence, very small amount of signal will pass through one stage to the next stage. Hence, very small amount of signal will pass through one stage to the next stage. Okay. So, moreover, CE cannot shunt the emitter resistance RE effectively because of its large reactance at low frequency. I repeat this point. Moreover, CE cannot shunt the emitter resistance RE. And if it is not connected parallel with RE, CE is not connected parallel with RE, so effectively because of its large reactance at low frequencies. So these two factors causes the voltage gain fall at low frequencies. Okay. Second one is the mid frequency range. Second one is the mid frequency range. What is the frequency range of mid frequency range? 50 Hz to 20 kilohertz. 50 Hz to 20 kilohertz. In this range of frequencies, voltage gain of amplifier is constant. Gain of amplifier is constant. This is due to the reactance of coupling capacitor will be very small, that it can be neglected. So, in this range of amplifier maintains a uniform voltage gain. In this range, amplifier maintains a uniform voltage gain. Okay. So, next one, third one is the high frequency range. Third one is the high frequency range. So, as the frequency of input signal increases, the gain of amplifier is decreases. Frequency of input signal increases, the gain of amplifier is decreases. Two important factors are responsible this reduction of gain. See this waveform, see this response curve. After 20 kilohertz, gain decreases, frequency increases. Okay. So mid frequency, in this mid frequency range, gain is constant. Gain is constant up to frequency range. Okay. So next, high frequency range. As the frequency of input signal increases, the gain of amplifier is decreases. Two important factors are responsible this reduction of gain. First one is reduction of gain at high frequencies is due to interelectrode capacitances between the junctions of the transistors. Reduction of gain at high frequencies is due to interelectrode capacitances between the junctions of the transistors. So the products, they produce a shunting effect. Shunting effect means it is nothing but short circuit. They produce a shunting effect at high frequencies at input and output sides. Because of the shunting effect, the voltage gain is reduces at high frequencies. Okay. Next, second point. In this range of frequency, the capacitance of coupling capacitor is very small and it behaves as a short circuit. This increases the loading effect of next stage. Here, RC will comes in parallel with R1 and reduces the voltage gain. This reduces the current amplification, thereby the voltage drops at high frequencies. Okay. This is nothing but frequency response of two-stage RC coupled amplifier. Working principle over frequency response two-stage RC coupled amplifier also over. Next, advantages and disadvantages of RC coupled amplifier. Advantages and disadvantages of RC coupled amplifier. First one, we can discuss about advantages of two-stage RC coupled amplifier. So here, the frequency response is excellent. Excellent frequency response forms this two-stage RC coupled amplifier. That is one advantage. The second advantage is the circuit is very compact and extremely light. The circuit is very compact and extremely light. And third advantage is cost is low because it employs resistors and capacitors which are cheap. Here only resistors and capacitors are connected. That's why so cost is low. These are the advantages of two-stage RC coupled amplifier. And next, disadvantages of two-stage RC coupled amplifier. So first one, low voltage and power gain. Here, so this method offers low voltage and low power gain. Okay, that is the disadvantage. So second disadvantage is they have the tendency to become noisy with age. They have the tendency to become noisy with age. And third disadvantage is the impedance matching is poor. Impedance matching is poor. It is because the output impedance of RC coupled amplifier is several hundred ohms. Okay, so impedance matching is very poor. It is because the output impedance of RC coupled amplifier is several hundred ohms. Okay, so the RC coupled amplifiers have excellent audio fidelity over a wide range of frequency. Therefore, they are widely used as voltage amplifiers. That means pre-amplifiers. So for example, public addressing system. Okay, so these are the different advantages and disadvantages of two-stage RC coupled amplifier. Okay, next, summary of this presentation. We have seen working of two-stage RC coupled amplifier. And also subtopic of two-stage RC coupled amplifier is frequency response of two-stage RC coupled amplifier. Okay, next, frequently asked questions may be asked. The first question is, draw and explain the two-stage RC coupled amplifier with circuit diagram. So this question may also be asked. Draw the circuit diagram of two-stage RC coupled amplifier. And also may be asked this question, explain about, write down briefly two-stage RC coupled amplifier. Or also may be asked, write down the advantages and disadvantages of two-stage RC coupled amplifier. Okay, so this topic may be asked different type of questions. And the second question is, explain the frequency response of two-stage RC coupled amplifier. Explain the frequency response of two-stage RC coupled amplifier with circuit diagram. This question may also be asked as, draw the frequency response curve of two-stage RC coupled amplifier. Okay, so these are very important questions. Advantages, disadvantages. Advantages is nothing but also applications or uses are same. So frequency response of RC coupled amplifier is very important. So gain formula, total gain formula also important in two-stage RC coupled amplifier. So total gain is nothing but gain of first stage to the into gain of second stage. Gain of first stage into gain of second stage. Okay, so this is the figure. Figure also very important, simple and easy figure. Okay, so these topics are completed. Okay, thank you.